Right now, we're going to look at some of the rules for integration. Finding the indefinite integral is called integration. So integration is finding the indefinite integral. The rules for integration are basically just the reverse of the rules for doing the derivative. A lot of these are going to look really familiar. If we have a constant in front of and multiplied by a function, and we want to integrate that, if we want to find the indefinite integral of constant times f of x, what we can do is we can find the indefinite integral of f of x and then multiply it by that constant number. Notice I'm using lowercase c here, so as not to get it confused with the constant that we add a plus c at the end to. Well, another rule for integration, another rule for finding the indefinite integral, is if I have two components, f plus g, and I want to integrate their sum, I can integrate each one individually. We actually used this on the examples we did earlier. We integrated term by term. So we found the antiderivative of one of the terms plus the antiderivative of another term. Another thing we saw earlier was that if you do an antiderivative of 0, you get any constant that you want, because any constant has derivative of 0. Again, we're going to denote the constant, the plus c at the end, as a capital C. These are basic intuitive rules for integration. Most people understand those. Now let's go to the rules of integration that really reverse our rules for derivatives. For instance, what if we want to find the antiderivative of x to the nth power? Well, a polynomial piece, normally we'd bring the exponent down front and lower it by 1. So if I want to find the antiderivative, what I need to do is I need to increase the exponent by 1. And then instead of multiplying the coefficient, I need to divide the coefficient by the new exponent, the n plus 1. So this is the power rule in reverse. Obviously, if we're finding the indefinite integral, we have to tack on a plus c at the end. Now that works as long as n is not equal to -1, because when n is equal to -1, I get a denominator of 0 here, which is undefined. But when n is equal to -1, x to the -1 power is just 1 over x. And we should know that the antiderivative of 1 over x is natural log of x plus any constant that we want. The reason we should know that is because we know the derivative of natural log is 1 over x. So as long as we have natural log of x, derivative is 1 over x. The plus c, when I take a derivative, turns into 0. So the antiderivative of 1 over x is natural log of x. This shows me how to integrate any polynomial that we want or any rational 1 over x to a power. Even if n is negative, this will work. As long as n is not -1, this rule works. If n is equal to -1, then we're in this scenario on bottom. So any polynomials, we're going to utilize these rules here. Integrating x to the n, utilizing that we can integrate each term individually, and then constants, we can integrate this piece multiplied times c. Other derivatives that we saw, well, we had seen that if you take a derivative of e to the ax, you get e to the ax back, and then you multiply times a. If I want to reverse that process, I start with e to the ax, I get back an e to the ax, but instead of multiplying by a, since we're reversing the process, we're going to divide by a. And then obviously we tack on a plus c, because when you do an indefinite integral, you have to find all antiderivatives. Letting c be constant gives me all antiderivatives. By c being constant, I mean an arbitrary constant number. The same thing is true for a to the x power. If you remember, when we took derivatives of a different base to the power x, we had to multiply times natural log of a at the end. Well, if I take an antiderivative of a to the x, I get back a to the x, and then I have to divide by natural log of a. Again, this is simply reversing the derivative rule. So dividing by natural log of a when I integrate and find the indefinite integral. Obviously, the plus c is tacked on at the end. Let's go and find the antiderivatives of cosine x. Well, what trig function gives me derivative of cosine? That's positive sine. Remember, if I take a derivative of sine, I get a positive cosine. Now here's the tricky part. If I want to integrate sine of x, I need to take negative cosine. The derivative of cosine is negative sine. So in order to get rid of the negative, I have to throw a negative out front. So when I take a derivative of sine becomes cosine. Derivative of negative cosine becomes positive sine. I always have to tack on a plus c when I'm doing an indefinite integral, because I want the class of all antiderivatives. Other rules, well, if you took a derivative of tangent, we saw that you would have gotten secant squared. So the antiderivative of secant squared is tangent. The indefinite integral is tangent of x plus c. When you take a derivative of secant, you get secant times tangent. So if you integrate secant times tangent, you get secant plus c. Derivative of cosecant is negative cosecant times cotangent. So if I have a cosecant cotangent, when I integrate that, I get negative cosecant plus c. This is usually how it's written, although obviously I can change where the negatives are. If you want to put the negative on the left-hand side of this equation instead of the right-hand side of the equation, that's fine as well. Derivative of cotangent is negative cosecant squared. So if I want to integrate cosecant squared, I'm going to get negative cotangent of x plus an arbitrary constant of c. These are the big rules for integration. Knowing my trig function, antiderivatives, knowing my exponential function, antiderivative, knowing polynomial antiderivatives will get me pretty far in this class. At least in chapter 5 it will. Let's go ahead and use what we just learned to evaluate some of these indefinite integrals. Just a forewarning, this concept of finding an antiderivative is a big deal. We're going to be doing this quite a lot. Moreover, if you go on to Calculus 2, you're going to be doing this a lot. Calc 2 is all about finding lots and lots of antiderivatives and then being able to use them in scenarios. Let's go ahead and find the indefinite integral for these two functions here. If I take 18x squared, what I'm going to do is I'm going to focus on the x part first. Raise the exponent by 1, and then deal with the coefficient. The coefficient is my old coefficient, 18, divided by 3. Once again, I'm using that power rule that we saw earlier. If I have a constant number, that minus 5 is like minus 5 times x to the 0. So in order to take an antiderivative of negative 5, I want to basically just tack on an x so that when I take the derivative, I get negative 5 times x to the 0, which is just negative 5. So if ever you're finding the indefinite integral of a constant number, you just take that constant number times x. And then we always have to tack on our arbitrary constant of plus c. I usually clean this up. If 18 over 3 has a nice whole number form, I just give that whole number form. In this case, 18 divided by 3 is 6. So the final answer would have been 6x to the third power minus 5x plus c. In this scenario where we have 4 over x to the third, don't get confused. 4 over x to the third, we're not going to be dealing with natural log because this is not an x to the negative 1 power. This is an x to the negative 3 power. This is equivalent to 4x to the negative 3 integrated with respect to x. So I can use the same rule I used up here. I can look at that x to the negative 3 power and say I want to add 1 to the exponent. Be careful, negative 3 plus 1 becomes a negative 2. And then I'm going to take the 4 and divide by that new coefficient. The new coefficient, the n plus 1, is negative 2. And then I'm going to add a plus c. If I want to clean this up a little bit, that is negative 2 x to the negative 2 plus c. Now this is the answer written with negative exponents. If you want to write your answer with positive exponents, that's easy to do as well. We'd take -2 over x squared plus c. Whenever you multiply by a variable with a negative exponent, you could have just as easily divided by that variable to a positive exponent. Either one of these two answers would be acceptable to me. When you're writing down your answer in Moodle, be careful because sometimes Moodle may say write your answer with positive exponents, and sometimes Moodle may say write your answer with negative exponents. I'm not sure if Moodle has an advanced enough system to recognize that multiplying times x to the -2 is the same thing as dividing by x squared. It may or it may not. Again, I'm not for sure on how advanced Moodle's learning system is. I would like you to take a look at these two indefinite integrals. I want you to integrate in each case and find the indefinite integral. Go ahead and push pause on the video, and on the next video, we'll try and do it.